Hello, and welcome to the Solid State Lighting Design Workshop. My name is Michael Denninger, and I'm a lecturer here at the Lighting Design Center. And I have a bachelor's and master's degree in mechanical engineering, and I have a working background in lighting design, so using LEDs, so mechanical design, thermal, optical, and device level. And what I really find interesting about this course is it's just that, is the disciplines that interweave. So if you're a mechanical engineer, you'll be a pretty good electrical engineer when we're done with this course. And if you're an optical engineer, you'll understand mechanical and so on. So it's really, I learn something new every time I do this, and every time I design a product, and I think you'll find the same. The course is divided into 9 parts or modules, and so looking at the syllabus together, it's really, we'll go over things like the first module is luminaire design, so overall product, and then we'll look into details, LED device overview, so the sources themselves, optical design, is it a flashlight, is it a area light in an office? Those have quite different design criteria and different parameters. Heat transfer, is it a product you touch, is it a product can be hotter, it's in an enclosure or something, and we'll go over how to calculate temperatures and how to, and we'll measure temperatures in products. LED power supply design, so is that a battery powered product, is it mains voltage in your home, or is it, an industrial setting with a higher voltage? And those are a lot of different specific requirements. We'll go over reliability testing, so how do we know the product's going to last for the design, the service life that it's intended to be, and how do we set up a test like that. And we'll go over the safety certification process, so we know the products we're building are safe. And we'll just review design requirements as a whole. So that really, that goes over the nine components that'll make up this course. Are there any questions with that? Okay, so the grading for this course, it's pretty straightforward. It's there will be a take-home exam after each module, and it will cover the material which we covered in that module, and it'll be due in the next class, at the beginning of the next class. If it's a situation where you miss a class, then you'll have to work from the notes and complete the assignment through that, and those notes are available online. And if you can't complete the assignment on time, that is something you'll have to request an extension for. So there's certainly extenuating circumstances. Things happen outside the course that you can't control, and so if something like that happens and you can't meet the requirement, just see me, request an extension, and we'll take care of it. Any questions on the grading? Okay, so for today's lesson, we're going to have a brief overview of the UL safety certification process for solid state lighting, and specifically for light bulbs. So, something like this, like a standard light bulb you put in a lamp or socket in your house. And in terms of safety certification, there's really a few questions to ask about that. And why is it important? And can I buy a bulb that doesn't have a safety certification on it? Are they available out there? And how do I know the bulbs I'm purchasing and the ones that are going to people's homes? How do you know those are safety certified? So, and we'll come back to those questions in a moment. But I want to go over a brief overview of just what the certification process looks like. So, Underwriters Laboratory determines what tests we do. So they write the standards, which are for each particular type of luminaire, and they determine values and test methods for each one to meet each of these criteria. So there's several different labs out there that actually can do the testing, so ETL or TUV and UL itself, but really UL is the one in the US that generates that specification. And what UL is really worried about, it kind of simplifies it 2 things. With electrical lighting as a whole, they're worried about fire and they're worried about electrocution. So you don't want a product in a house that has has unsafe failure modes where it may catch fire, and that has to do with materials used. Is it glass, metal, plastic? And each one has different criteria where it can be used. And plastics, some burn, some self-extinguish, some don't burn much at all. So particular plastics will be better. And also what happens in a fault condition, like how many times have you put a light bulb in and it dropped and hit the floor? is that product now unsafe? Is there something, has geometry changed because of the impact, and do we have to worry about that? And electrocution is really just access to the 110 AC. So if it's a plug in your home, in this case a light bulb and plug in your home, is there a risk that you can become connected to that? So, and that has to do with mechanical spacing. So there's live wires inside the product close to exterior touchable components. And what are those materials? Are they isolative? Are there, there's conditions there? And also the same fault conditions. Does the bulb get dropped? Does it crack? Does something happen? And now it becomes an unsafe product where previously was fine. So those are really what UL's worried about. Are there any questions on that? Okay, so the process basically from top to bottom for the actual certification is you generate a concept as a product designer, and you create prototypes, and then pre-production and production. But somewhere around the pre-production stage, you arrange with a testing lab to do this, and they will request samples, and they'll tell you what they're for. Some are destructive, some they short parts of it, or they take it apart and do something to it. Some they just measure temperatures or electrical parameters. So you send them the required samples, they do the testing, and a report is generated. And sometimes that needs a little back and forth. Might be minor modification you need to do, or they may bring up things, and some of them are critical. They can't, for them to certify. Some are just stuff they need to see. Sometimes it's just the wording on the outside of the bulb, the labeling, the font, details like that. So when that's complete and they're satisfied with it, what you ultimately get as a tangible product is a certification, which is an authorization mark. So you get a letter that says that you can use the UL or the Intertech or TUV logo on the outside of your product. And that tells a consumer that product has been listed, it's safe, has a listing number on it. The listing number can be looked up anywhere, and you can see what it was tested under, what conditions, and what it meets. So that's basically the testing process. But back to the three questions, though. Why is it important? And one of them is just we want to make sure we put safe products out in the market. If it goes in a home or something, we want to know that we're doing the right thing, and that also reduces liability to the company. So we want to make sure that we test something and it meets criteria. Also, mainstream retail will not accept a product on their shelf without it. So that would be a Best Buy, Home Depot, Lowe's. Any company that's going to put a product on a shelf, they'll require it. Second question is, could you buy a product that does not have safety certification? And you certainly can. I have a bulb right here. This bulb has no markings on it, so there's no print on it, doesn't tell me anything about it. And you can do that, but you may even test it and say it meets the criteria, but you didn't get it certified. So that becomes a matter of, if there's a fire in someone's home or something, homeowners insurance will generally not, they'll invalidate if that product was involved in it. So you don't want to do that. And also, and as question one, mainstream retail won't put it in their stores without certification. So, and if you want to know if it was tested, any product that's purchased, the UL logo would be on there. So it's usually printed here. It's got a listing number on it. Same with this guy. It's got an ETL logo here and a listing number. Are there any questions with regards to those criteria? Okay, so this concludes the introductory part of this. So this just tells us, why we're worried about it and what testing is actually done and some of the important details. The next class will go over we'll go through a test report and look at how a product was designed to meet that. So the materials chosen, spacing, all the criteria I brought up at the front end of this, and that will give us a more of a view of how we design a product, so when it gets to certification it passes and we don't have to go back through and make costly changes. Thank you for your time, and we'll see you next class.